get it sorted now. Okay, so real quick, go through all these again. Create what will be the primary keys on the first one. It has a data type that goes through all the tables. It's got this little tag bit at the top. Drop goes through all the tables and purchase the recycling bin. Constraints starts with the primary keys, then it goes into the foreign keys, and then it adds the not null and unique constraints and the check constraints. Tonya, do you want to go through the inserts?
Yeah, sure. So for the inserts, there are 5 entries for each table, and the order of the entries is in respect to the order of the tables, how they were created. Back to you, Jack.
That's all for now. We can't run the files because Oracle is acting up. So we'll add that on when we get the footage of it. And then after this, Aaron's got a recording of going through the queries, which will be added on. Oh, and we're group 20, if you need to know.
Like this. So we're going to start from the select query. We've got a query to return all records from schools. So I've just done select all from schools. Don't mind the comments. I'm going to go ahead and try and redo those later. They are a little bit weird. Then we've got another select query. It's a projection query this time. And these are the columns from the schools are sorted by name. So they're done in reverse alphabetical descending order. We've got descending here. We've got from schools. We've got these 3 columns which I've selected. We've done it from schools. These 3 columns are from schools. I thought these were the best ones to use. Then we got it ordered by, so it should be ordered in descending order based on the letter that it starts with. Then we have restriction, which is a return. A restriction will return any applicants who live in Northampton by joining schools and applicants whilst restricting by town. So we've got to select, we've got the first name, we've got the second name, and these are from applicants. Don't know why I've included email in there, but I thought maybe that would be the best way to sort of represent an applicant better. It's going to join schools, and it's going to join schools. So we've got the primary key school ID, and then we've got the foreign key school ID on applicants. So it's going to join these 2 together. So we'll have, and it's going to be where the town is Northampton. So they have to have Northampton as their town, basically. Now we've got a pattern matching query, and this will return applicants who have their first name begin with M. This will use a like pattern match. So like is a pattern matching sort of code. And this uses the first name, second name, and email from applicants, and it's going to match it. It's going to have just people with their name, first name beginning with M, and it's going to list these with their second name and email. Then we have a negative condition. It's going to return applicants who don't live in Northampton. It's going to use a negative condition. So this is going to be from applicants, and it's going to join schools. This is the schools. This is their primary key, school ID, and then we've got the applicants' foreign key here. So it's going to return applicants who don't live in Northampton, basically. It's going to be where not schools.town. .town, so town within schools is Northampton. I haven't used aliases, and I think I'm going to change the code to use aliases. For joins, I have, but I haven't just done a single letter. I've done full words like schools.town, you know. Then we move on to the logical operator, and this is going to return any applicants who are adults, classes 18 or over, and who live in Northampton. It's going to utilize a logical AND operator. So we've got first name, second name, we've got the date of birth of an applicant. And it's going to join on school ID, which is a primary key in schools. Applicants has a foreign key school ID, and they have to have town being Northampton. So then we move on to the logical operator, another logical operator, but this is going to return applicants who are either children, which is classes under 18, or those who don't have an email address. So it's going to use a logical OR this time. So the other one was a logical AND. There's going to be an OR, so there I've used 3 columns here, first name, second name, and email from the applicants table, And we've also then said that they have to be children under 18 and they don't have an email address, basically. Then we have a date range, and this will give us applications made during 2026 using a between date range. So we've used between here. I'm not sure if you use it, but this is how I do SQL anyway. But we do it between two different dates, which will basically be from the start of 2026 to the end of 2026. And I've selected these two from applications. So we've got the primary key and we've got an application date. And it's basically going to give us all of the applications that are made during 2026, basically, from the applications table. Then we have a join with two tables. So this is going to return the names of the applicants and their grades. This is done by joining results and applicants together. So we've got the first name, second name, and grade. This is going to be selected from applicants, and we're going to join it with results. Well, obviously the grade is going to be from results, obviously, right? So it's going to be joined on applicant ID. The results has a foreign key applicant ID, and applicants has an applicant ID primary key. So then we have a join table with three tables, and this is going to return the names of the applicants and title of course they are taking. This is done by joining the applicants, applications, and courses table together. So I thought this was quite an interesting one. I couldn't really think of one for this one, but I've gone ahead and gone with a first name, second name, title, and this title will be from courses, and the applicants will have their first name, second name, and it's going to be joined on the applicant ID once again. Applications will be joined to applicants on the applicant ID, and then we then join courses from the course code foreign key in the applications table, and then we've got the course code, course underscore code in courses, which is a primary key. Last query, we have a multi-table complex query. This will return the details of an applicant, the course title, and the name of the university, and it's also going to return the application dates for applications made past 2026. And the query shows a multi-table join. So I think it's like 4, 1, 2, 3, or 3. Yeah, it might be 4. Yeah, it's 4 tables are going to be joined together. So I use first name, second name from the applicants table. The title comes from the course table. University underscore name comes from the university table. And the application underscore date comes from the applications table. So if we run through it real quick, we have it's from applications. It's going to join applicants. It's going to join applications. Applicants has an applicant ID, and it's going to join with applications, which has a foreign key applicant ID. We're going to use courses. It's going to also join. It's going to join onto applications. It's going to keep joining. It's going to join onto applications. And courses has a course underscore code. And course underscore code is within applications as a foreign key. We're going to join universities onto that, and we're going to join universities via the university underscore ID, which is the primary key of universities. So we've got courses, which has a university underscore ID foreign key, and we're going to do this where applications are made past 2026, right? And we're going to order it via the second name. And yeah, so just going to check again. So we've gone through the projections, restrictions, predictates, logical, comparative operators. I've used a join, multi-joins. Complex query has been done. This is the complex query. We've done multi-joins in 3 actually. The 3 tables is a multi-join. So entity and referential integrity is actually adhered to by only joining tables only through valid primary and foreign key relationships. So there's no invalid joins that are going to be used here, right? The results will be checked when someone runs it. My Oracle isn't working. It got corrupt or something. I was using Oracle for another project and it got corrupt. So hopefully someone can run it and show that it does work. The comments will be redone. There's some comments I need redone. I think this is a bad structure for comments anyway. And there will be headings. So yeah, thank you.